Assalamu alaikum wa rahmatullahi wa barakatuh. Now we will talk about quality metrics of OSCE, part 2. OSCE metrics are tools to answer our evaluation question. In part 1, we have discussed how to assess validity of the exam, how to assess reliability, and how to measure Cronbach alpha and factors affecting Cronbach alpha. Now we will talk about where all students subjected to equivalent examination conditions between group variance, what can possibly affect students' marks in OSCE. We need the only variable, the only variation between students is the student performance only. There is a circuit of variations like equipments, assessor, layout, and simulated patients. Ideally, all marks variation are due to difference in student performance only, not differences in marks due to the differences in the assessors, differences in the equipments of the exam, differences in the standard or simulated patients, and so on. We need to assess the performance. Given that students are randomly allocated to circuits like this and special groups aggregated in circuits should be cancelled from the analysis. And that circuit layout, simulated patient, and equipments are standardized across different circuits. Same equipments, same layout, and the same training for simulated patient. Between group variance is measured by one-way analysis of variance by ANOVA. Ideally, between group variance should be under 30%. But for example, station 4, between group variance here is 50%. Potential inconsistent assessor behavior and or other circuit-specific problem may be the cause of this defect in station 4. There is difference between the assessors like Hauck or Dove. Sometimes Hauck is ask students difficult questions, has tough tools of dealing with students, while Dove asks students in a friendly manner and so on. This may affect the between group variance. Are there other factors to consider in evaluation of OSCE? Number of failures is very important to look for. We can illustrate this by deficient teaching. Deficient teaching may be a cause of increasing the number of failures. Number 2, faulty standard set. Number 3, unclear instructions for the OSCE exam. Number 4, poor performance of simulated patients. That's to say, simulated patients don't receive proper training. Number 5, exam not aligned to ILOs of the course. If a standard setting tool is used, extra metrics can be applied, which is the R2 coefficient of determination. What is R2 coefficient? It is the correlation between checklist score in the OSCE exam and the global rating score. This is global rating score horizontally and vertically the checklist score. In this, there is good correlation between checklist score and global rating score. R2 coefficient more than 0.5. Let's see the next diagram like this. The relation between checklist score and the global rating score are two coefficient below 0.5, which is poor correlation or not accepted. What is the cause of poor correlation R2? Poor checklist design is an important cause. Number two, mismatch between checklist and ILOs understood by assessors. Don't forget to take the feedback of students, examiners, simulated patients after finishing the OSCE exam in order to assess difficulties, defects, and try to improve in the next exams. Be careful, no single metric is sufficient alone. You should check for validity, check for reliability by Cronbach alpha, and calculate the R2 coefficient, which is the correlation between checklist and the global rating score. It is a continuous cycle of evaluating the Cronbach alpha, number of failures, R2 coefficient, the feedback of a student, examiner, simulated patients, and between group variation. All these measures give you a good insight about the validity, reliability of the OSCE exam and the variation between different groups. What is the next step? You should make an adjustment of total marks for side effects, adjust to common mean across all sites, and removal of a station with rare multiple adverse metrics. How to avoid this? Number one, upgrade training methods for examiners and the simulating patients. Number two, improve the assessors briefing to avoid any misunderstanding. Number three, improve simulated patient briefing. Number four, detailed assessors support material. Equipments are very, very important. Number five, use of dummy runs. These are the references for my lecture, and at the end, thank you all.